All right, kids, trying something new. Got the screencast thing. I don't know if any of your other teachers have used it, but this will kind of allow me to talk to you guys and kind of show some visuals too. Today, I'm just going to work through the notes, but going forward, to show some cool pictures and things like that. But just kind of trying new things that I'm learning along the way. I'm going to try to keep it simple and not going to introduce too many crazy things. I know a lot of you guys have this medium or that medium. You got this, this thing you're working through at that class, this thing you're working through at this class. I'm going to try to keep it 365, just clicking. You guys are used to YouTube and kind of the things work within 365. I might use Edutech, where some teachers have been using. It looks pretty cool, but for trying to keep it simple. But this is a cool thing. It kind of let me, I don't know, I didn't figure this out to this week to kind of do a video and be able to kind of show you guys what I'm doing on the screen as well. But before I get into the nitty gritty of what we're going to talk about, I'm going to talk about the grading that's happening, right? Obviously, you guys saw it's kind of crazy. It can be hard to understand with the third quarter, fourth quarter thing. But fourth quarter thing, everything's 100 points at the end of every unit. I'll give you like some sort of a assessment, and it'll be a little bit more, not much, right? Your astronomy assessment was 400 points, whereas if you're basically doing this stuff and you're paying attention, not too crazy, you should be getting about 100 points in assignment. So, but I've been accepting lots of things late, and I'm totally, obviously fine with that. Everybody's got different stuff going on. We're learning new things, but going forward, it's going to be a little more rigid, right? You're only going to have one assignment from me a week. I'm going to give that assignment on Monday, and it's going to be very small of an assignment for the most part, most times. So I expect it done by Friday, right? If you have any trouble, let me know. Don't, text me Saturday morning or Friday night that you're having trouble with it. Just work through it through the week. I've been trying to get back to you guys at all hours, but work through it during the week and get done. You have any questions? I'm going to really not overwhelm you, but also don't take advantage of the system, right? We're giving a lot of leeway here, but don't in 3 weeks, like, I got to do all my assignments. So get it done. I'm not going to hammer you, but I definitely want you guys to kind of stay into. I want to teach the things that I think are important to you guys, are important to learn, and we'll get through this. So we're getting into meteorology now. So we're talking about the weather right now. I'll flip this around. You can see I'm actually recording this Sunday night. It's raining. It's been obviously kind of miserable out. Before I move on, the survey, guys, if you haven't done the survey, get the survey done. The reason I'm actually doing this Sunday is because one of the suggestions I got, someone actually said, hey, post it. I like it when it's posted the night before. I like it posted on Sunday night. So I'm trying to honor that. And a lot of different suggestions. I'll go over that more on Wednesday. I don't want to say too much because I just don't want people to copy what other people said. But do the survey. You'll get 5 bonus points added to your astronomy castle learning. Right, so I'll add that right to it. All the bonus points I'm going to add on to that as well. So some people did the other things. I haven't added those in yet, but I'll add that to the astronomy castle learning. But we're going to get into meteorology. Meteorology is the study of weather, the study of our atmosphere, and we live in a certain layer of the atmosphere called the troposphere. So if you see in the screen right here, this is on your reference tables, right? But I'm kind of isolating it here. So we have the troposphere down here, and we all live inside the troposphere. We've never been outside the troposphere. The only people who have been outside the troposphere are astronauts, or there's a couple of crazy skydivers. I'm actually going to send you as a link of this thing called Red Bull Stratos. Red Bull does all sorts of crazy extreme stuff. This guy did a skydiving thing from the stratosphere, which is up here. All right, he did it from the stratosphere, and he jumped down. It was the highest skydive ever. But you've never, even if you flew in a plane, you're flying to California, you're not outside the troposphere. The other thing about the troposphere is all water vapors in the troposphere. Outside of the troposphere, there's no water vapor. So you need to live in the troposphere. And you can see this chart. We have the altitude. We have in kilometers going up. We have in miles. We have the different layers, the troposphere, the stratosphere, the mesosphere, the thermosphere. And the pauses are kind of the boundaries between them, right? We have temperature on the bottom. As you go up, right, if you go to the top of a mountain, it's going to get colder, right? So if you're drawing a picturesque mountain scene, you're going to draw snow on the top of those mountains, right? It's just cold, right? Ski mountains, right? You're skiing down a mountain, obviously for the topography of it, but high elevation has a lower temperature, and the stratosphere is the opposite way. It gets warmer, then it gets colder, it gets warmer again. Atmospheric pressure, right? At the pressure, which is atmospheres, right? We talked about this. We talked about the inside of the earth, the pressure in atmospheres. One atmosphere is an ideal. That's about 15 pounds per square inch. You have about 15 pounds per square inch pushed on you. You might be like, I don't feel 15 pounds. Well, it's because you're used to it. Right? That's equilibrium. You have 15 pounds all around you. But when you change that equilibrium, when you go up in an airplane or you're going up a hill, an incline, up a mountain, your ears might pop, right? Because the pressure in your head is different than the pressure outside, right? It might bother you, you chew gum and yawn or whatever, and you're equalizing that pressure. Or if you dive down, if you guys have gone to the bottom of a pool or free dive, I try to do a little bit of spearfishing as a hobby of mine. I'm trying to get better at it. And one big thing, the biggest thing for me is to get better at something called clearing. When you go deep, I want to get down. My goal is to be like 30, 35 feet down. It's where a lot of the big fish are hanging out. You hold your nose and you pop. If you go like that, you pop your ears and you're equalizing. So you might have felt that if you ever gone to the bottom of the pool, if you pop your nose, you'll equalize. If you can't dive down unless they call it clearing. You can't dive down deep unless you clear. So that's a pressure difference, and it's ideal right here at sea levels where it's nice and comfortable, right? Water vapor, obviously we talked about most of the water vapor is down here on the surface of the earth, right? So now what we're breathing in, when you take a deep breath, we always think about oxygen, right? Well, we need oxygen. Oxygen is important. And this is from the front page of reference table. We live in the troposphere, and this is the troposphere right here. We actually breathe not a very high percentage of oxygen, which when we breathe in is less than a quarter of what we breathe in is oxygen. Only about 21% right here, oxygen is what we breathe in. Obviously, we need that to live. That's important. But 78% of what we breathe in is nitrogen, right? Most of the atmosphere is nitrogen down here, right? And then 1% other, that's carbon dioxide, other things, water vapor, pollutants, right? But you take a deep breath, it's 78% nitrogen. It's only 21% oxygen. If the atmosphere was 100% oxygen, everything would be on fire. That wouldn't be good if everything was burning, right? So we don't want 100% oxygen. That was something, if you watch the NASA video, that was a huge problem that happened with Apollo 1 that caused the Apollo 1 disaster. They pressurized the thing with 100% oxygen. There was a spark, and they couldn't get the door open, right? So we had 3 astronauts perish. So 100% oxygen is not good. You feel good if you have 100% oxygen. They give that to people who are sick or like you see a football game on the sideline, right? To rejuvenate you, but it's highly flammable. So that is the atmosphere. The troposphere is the most important part in which we live in, right? And we're going to talk more about these things. We'll talk about ozone and things like that. But as we're moving down here, we're going to get into weather. And the first 2 topics with weather, and when you talk about meteorology and the importance of it, it's one of the everybody on Earth, a high percentage of people on Earth, the first thing they think about when they wake up is meteorology, right? And what's the weather going to be like, right? Everybody checks the weather every day. I know I do. Right, wake up in the morning and you want to check the weather. You want to know if you're going to have not that anybody's doing anything now, has games or anything like that, but you want to know, am I going to have a game today? Is school going to be camp? Am I going to have a snow day? What should I wear today? Is it going to be raining? Is it going to be hot? Right? And you're looking at the weather. You're looking at a bunch of different factors. So some of the factors, what are the 2 major, I'm talking to you guys like you're here, I was about to ask a question. The 2 huge factors, which I'm going to talk about today, are temperature and moisture, right? Those are the big, if you could pick 2 of the factors you want to know about, it's how hot it's going to be and is it going to rain, right? Or is it going to snow? Those are the 2 main things you want to know about. There are so many other factors you probably not even hitting your brain right now. Think about wind, right? You think about cloud cover, right? You're thinking about humidity, which ties into moisture, right? All these different factors come into play when we're talking about the weather. But we're going to focus today on temperature and a little bit of moisture. I'm going to spend a lot of Wednesday on moisture. So we're talking about temperature, and this is the temperature scale here. Temperature is just how fast molecules are moving. If when we're asking how hot is it, you might as well say, well, how fast are the molecules moving outside, right? If it's hot, the molecules are moving fast, right? If it's slow, if it's cold, they're moving slower, right? That's all that temperature is, right? If there's more energy out there, it's hotter. If there's less, it's cooler. Uh, and this is how we measure temperature. We're really stupid in America with how we measure things. We measure things in Fahrenheit, right? Which is kind of a silly measurement. Everyone else uses Celsius. We also use feet and miles, which is also silly because it doesn't tie into each other, right? You ask how many feet are in a mile. It's kind of an arbitrary number. I think it's 5,280, something like that. I might say that wrong, but if you say how many meters in a kilometer is 1,000 meters in a kilometer, right? So it doesn't really make as much sense, but that's what we're stuck with here. So we use Fahrenheit, we use inches, we use miles, but Celsius is much nicer. Why? Because water freezing is 0, water boiling is 100, and obviously water is life. That's how we tie in everything. We want to know, what's freezing temperature, and obviously we want to know what the boiling temperature is. Not that we'll ever experience that outside, but it's a nice simple way of looking at things. So we have Fahrenheit, we have Celsius, then we have Kelvin. 0 degrees Kelvin is absolute zero, where molecules stop moving. They no longer move, right? You might think, well, this wood right here isn't moving. But this glass behind me, right, this window, it's moving. If you go to ancient churches in Europe and you look at the glass is actually thicker on the bottom because the molecules are moving, right? And the gravity pulls it down, and the glass will be thicker on the bottom than on the top. So molecules are moving in everything unless you're at absolute zero, which is 0 degrees Kelvin. And you can use this chart right here, and it will show you, right, Fahrenheit, Celsius, Kelvin, how they tie into each other. And all you got to do is to transfer. You don't need to memorize any formula. It's just to look here. So, for example, 32 degrees Fahrenheit is freezing. It is 0 degrees Celsius. That is 273 degrees Kelvin. So any questions on Fahrenheit, Celsius, Kelvin are on here or in your reference tables, right? Page 14. Just look up there, right? So that's temperature, the biggest factor you want to know about. And then there's moisture. I'm going to talk more about moisture on Wednesday. But moisture in the atmosphere, we have humidity. How humid is it, right? That's the percentage of moisture in the atmosphere. If there's more moisture, is a higher humidity. If there's less, right, moisture is a lower humidity. If there's 100% humidity, there's going to be some form of precipitation, right? Like right now, it's raining, right? It's 100% humidity. The dew point is the point at which dew forms. You walk out, you're late to the bus, you run across the grass, and your shoes get wet. Like the grass is always wet in the morning. Well, that's because it's cooler in the morning. And if the dew point and the temperature are the same, let's say that the dew point is here and the temperature is here, right? As the temperature gets lower, right, the coolest part of the day is about 4 o'clock in the morning. That's when dew forms, right? It's like when you have a cold can of soda in the fridge, right, and has that little the dew on there, right? Why does that look like? Why does it have the dew when you pull it out of the fridge? Well, because the can is colder than the atmosphere, and that's causing condensation. So dew, right, that like dew on the grass, dew point is the point at which dew forms. So right now, the temperature and the dew point are the same. So right now, I'm going to guess and say it's outside. I'm going to say it's 48 degrees right now, right? It's not great. 48 degrees, and the dew point is 48 degrees, because if it's raining, the dew point and the temperature are the same, right? That's a huge factor. Now, I'm going to spend a lot more time on this on Wednesday. The last thing is just precipitation, right? The types of moisture. 4 major types, right? Rain, snow, sleet, and hail. The first 2 are more common, and we all just saw hail the other day, right? It's associated with a thunderstorm, right? You can have hail, freezing things, right? You can have it in the summer, right? We're going to talk about all those things. So we're going to spend more. I'm going to really dive into moisture on Wednesday, but that is the lesson for Monday. Your assignment, answer the 10 questions based on this lecture and based on the notes. I'll post this in the notes, which was another suggestion. Some of you guys wanted some more notes to accompany the videos. Answer the questions. Super simple. It's 10 questions. I put it, another suggestion I got was to put it in the Microsoft Forms. So I'm doing that. Right, I'm putting in Microsoft Forms rather than just kind of asking it to you guys. So I'm learning how to use that stuff too. And that's it. Hope you guys are doing well. I'll put another video out on Wednesday, and that's it. All right. Have a good one.